alright. Okay, let's just go through the answers, then we can start a bit of alkene. Alkene can be a bit fast because it's mostly just reactions. Okay, I've corrected some parts of this. Now, just to give you a bit of comment, this is basically free radical reaction. This is an example of how a question generally can be, but the question that you guys given here is quite detailed. They already tell you that they want the mechanism for initiation, propagation, and the termination step. The questions can be like this, broken down, or they can be as simple as give us the reaction, they just give you a lump of 4 marks. So that can happen as well. Now, it's important that you get the hydrocarbon correct, because that affects everything. And how do we look for points, or simply how do I make sure that this is correct? So in the initiation, you have to indicate the presence of UV, and remember to use to use a formula, because when you write equations, we use formula. You do not use the structure in the formula, especially when the question says write the full equation. Like here, you can see that when the question says write full equation, but what I have here is a structure. This is what we call as a condensed structure. It's still a structure. We do that when we are asked to draw. Okay? So as an equation, what we do is we just put the formula in. So it's C2H6, Br, HBr, C2H5Br. Instead of, see what happens when you do this, you have just practically tried to draw the structure out. Don't do that. That's not an equation. That's you drawing out the structure. Okay? Propagation step, simple. It starts with a radical, and very often, please remember, your radical in the first step, this is very important, the radical in the first step has to be from the halogen. Okay? And that leads to formation of a radical from the hydrocarbon. That takes you to the second step. The radical of the hydrocarbon will attack the halogen, which will again generate the radical of the halogen, and this kind of starts back the first step. This is important. So you can see here, this is a correct propagation. Can we use this propagation to evaluate the second question's propagation I have here? What's the problem with this propagation here? What is the issue? Can you guys spot the issue? Let's see here. The first step starts with a free radical of a halogen. That's fine. But you see the product here, I do not have a organic molecule radical. I don't have that. Instead, I have a hydrogen radical here. That is wrong. Okay? Remember, the first step is to produce, it starts with a free radical of a halogen, and you need to produce the organic molecule radical. That's important. Okay? So how can we change this answer now? So, the Br will get a hydrogen, so it becomes a HBr, and you will get a C2H5 radical. H5, and I put a dot here, that's a radical. Okay? So we have a C2H5 radical, we can put the dot here as well if you want to, it's the same. Alright? And that is what starts off the second reaction. So the radical will go on to attack. I can put it here as well. I don't know, somewhat makes me happy to put it here. Okay, so this attacks this, that gives us not HBr, it gives us C2H5Br and a Br radical that starts back the reaction. That's a correct propagation. See, that's how you realize that you can actually realize there's a problem with your answer if your termination step does not even have one organic molecule in it. There is a problem, right? The termination step should have an organic molecule in it. So there is no H radical at all in this reaction. So there is no idea of formation of HBr as a termination step. No, it is a product, but it is not a termination step. So a Br can react with another Br to give us a Br2. That's a termination. Again, no hydrogen radical, so I need to remove that. I already given you guys this. So what is the other termination step that's possible? So I can take a Br radical can react with a C2H5 radical. That will give us C2H5Br. Now this is the only organic product that we have from the termination step. You need to remember that, because sometimes question can be very specific. They can say that please give the organic product of the termination step. Okay? And then what else termination can we do? Normally how many steps we get out of termination? We can get 3 different equations, 3 different possible terminations. So what's one more? Yes, C2H5 with C2H5. This is our next. So we get C4H10. This is also our organic product. Now, how if the question wants to differentiate? How if I want to ask you guys to form this is what I want, then normally how can I say? If the exam question says please give the organic product, then you have a choice of these two. But if the question says please give the halogenoalkane, then there's only one choice here. There's only one halogenoalkane being formed from the termination step. If the question says please give the alkane, then you have to just give this. That's not a halogen. So you have to know the difference. Alright? If you just say organic, they're both organic. But this is the only halogenoalkane, this is only alkane. And in fact, this is a process that doubles the size of your alkane. From C2, it became C4. Yes? Oh, you didn't? That means you are not writing an equation, you are drawing a structure. So when writing an equation, you must use the formula. If the question says write the mechanism, yes. They say explain the mechanism, yes, you can go on and draw it. But you can do this, it actually saves you time. Right? You just total up. Alright? Okay? So that's the change that we need for 2. And it says, we go back to 1. We haven't talked about termination. So the termination here is all correct. This is good. The condition required is sunlight. Like I said, shapes will not be in exam. We don't do shapes this semester. We have done shapes in last semester, but in this, if you want to figure out the shape, it's quite easy. Having a chlorine on top will usually create a bigger push. Because chlorine is more electronegative, there's more lone pairs around the chlorine, it tends to repel all the hydrogen down. So there is an equal angle between the hydrogens, but there's a greater angle here between the chlorine and the hydrogen itself. So normally it gives us a shape. Is this tetrahedral? It is pyramidal. Okay, pyramidal, because you see that it has a smaller angle at the bottom of the above. But again, we've done this last semester, so this is just a revisit. But there will be, it will not be in exams. Okay, so that's question 1 and 2. Any questions? Any doubts?
So if you
yes.
Explain the mechanism for reaction, can I just answer the whole thing with equations? Do I need to explain?
Yes. No. You can give the equations. You need to look at the marks. So usually each equation that you write will give you a mark. So that's one, because termination, it's not a must that you give all 3. You just need to give me one termination minimum, unless the question says more. And the question sometimes might be very specific in which termination they want. So if it's just 4 marks, then the equation is good enough, because that's already explaining. But you do have to label each step, and you do have to include the condition. Like for example, in initiation, you do have to give the UV. So yes, to answer your question, you can just give the equations, but you make sure that it is complete. If there is curly arrows, then you have to give the curly arrows, because that forms the sort of explanation that we put into our mechanism. Yes. Yeah, Nitya.
So for the mechanism, we don't have to draw the actual diagram of the...
No, you can just use formula like this. Yes, that's fine. Alright? That's fine for free radical. Even for other mechanisms that we have done so far, like the halogenoalkane reactions, like the nucleophilic substitution or electrophilic addition, what you can do is you do need to show the structure, but you can condense it. So it doesn't have to be a full out structure. We can condense the molecules. The side chains can be condensed to make it very clear. Yeah. All right. Okay. So that's 1 and 2. Let's look at question 3. So what's in question 3?